Hello, and welcome to Sleepy Science Stories. I'm glad you've arrived here tonight, maybe already lying down, the lights low, the air quiet, the world easing into stillness. Outside your window, the night stretches wide. Stars breathe softly above the horizon. The earth turns gently beneath you, carrying every thought, every dream through the quiet sea of space. Tonight we travel outward far beyond our skies, past the thin blue edge of our atmosphere, past the shimmer of the planets and the faint ring of dust and light. We drift to the very limits of what humanity can see. What lies there at the edge of the known universe? What has NASA seen through its patient eyes? The telescopes that gaze through darkness, that listen to the oldest light still moving through space. Tonight, we'll move through time as much as through distance, from the newest observatories to the oldest travelers, from the shining birthplaces of stars to the quiet boundaries where galaxies fade into the unknown. If you find peace in these slow explorations, a soft tap on the like or subscribe button helps other sleepy minds find their way here too, one quiet soul at a time. Let your breath slow. Let your thoughts soften as we begin our journey outward, one quiet orbit at a time. Even as you rest here, the universe continues its slow, endless unfolding. Somewhere far beyond the clouds, above the winds and light of Earth, a single golden mirror floats in silence. It drifts not around our planet, but around the sun, 500,000 miles away, balanced on a quiet point in space. This is the James Webb Space Telescope, humanity's newest eye into the deep and ancient dark. It is vast, delicate, and impossibly precise, a machine built to listen to the earliest whispers of creation. When its mirrors first opened in 2021, it joined a lineage of human wonder that began with Galileo's lens and stretched through Hubble's silver gaze. Webb is not just another telescope. It is a time machine tuned to the faintest light that has traveled for more than 13 billion years to reach the fragile sensors of a human-made eye. It cost $10 billion to build 10 billion tiny decisions, 10 billion acts of faith that the dark could be measured and that the beginning of everything might still be glowing just beyond our reach. It took decades to plan thousands of minds to shape and one perfect moment to unfold in the cold beyond the moon. Webb's mirror is gold. 18 hexagons arranged like a honeycomb, each one reflecting not visible light like a regular mirror, but infrared light stretched by time and distance until it hums like gentle heat in the blackness. The entire mirror is 6 times larger than Hubble's, collecting more light, more history, more of what has traveled too far to be seen by any other means. Infrared light is not the glow we see with our eyes. It is older, deeper, quieter. It moves through dust and shadow, through the veils that hide stars in the moment of their birth. And Webb is built to see that hidden light. It does not simply watch the cosmos. It listens to the warmth between the stars. In its first months of vision, Webb revealed the unseen new stars forming inside clouds of gas, ancient galaxies, whose light began just after the Big Bang, the delicate rings of dying suns dissolving into space. Every image is both a beginning and an ending frozen together in one perfect frame. One of the first images Webb sent home was called the Cosmic Cliffs. It shows a ridge of golden light rising like a mountain made of fire. But what you see is not rock or flame. It is a stellar nursery, the edge of the Carina Nebula, a vast region where stars are being born from gas and dust, too dense to let ordinary light escape. Webb's infrared eyes slip between the shadows and show the glowing interiors, stars only a few thousand years old, blazing into existence behind curtains of hydrogen. It looks like a sunrise, but it is the creation of suns themselves. The next image showed another kind of story, a farewell, not a beginning. In the Southern Ring Nebula, a dying star releases its last breath. Its outer layers drift away in soft concentric rings, glowing like the petals of a fading flower. The central star, faint and small, has collapsed into a white dwarf, a remnant no larger than Earth, but holding the mass of the sun within it. Webb revealed what Hubble could not, the hidden companion star, the cooler dust, the fine tendrils that stretch outward for light years. Even in death, the star creates beauty, its elements scattering outward to form new worlds one day. Then came the Tarantula Nebula. It lies in a nearby galaxy, a sprawling web of blue and gold where young stars shimmer in swarms. It is the most active star-forming region near our own Milky Way, a nursery of extremes where the newborn suns are massive, hot, and short-lived. Hubble once captured its bright knots of light, but Webb revealed the filigree behind them. Cool dust sculpted by radiation shadows shaped by winds that move at hundreds of miles per second. In these webs of creation, gravity writes poetry in slow motion. And then Stephan's quintet, 5 galaxies, locked in a slow cosmic dance, their spiral arms tangled their stars intermingling. Some collide directly, others only brush against each other like waves meeting at sea. Webb's view showed not only the galaxies themselves, but the glowing gas where new stars ignite between them. These collisions are not violent in human time. They take hundreds of millions of years, but they are transformative. From the disorder, new structures emerge, and even chaos follows a pattern too vast for us to feel, except as wonder. And finally, the image that took humanity's breath and gave it back as quiet awe, Webb's first deep field. A window into time. Each point of light in that picture is a galaxy, some shining from 13.1 billion light-years away. You look at it, and you are looking back to when the first stars were still gathering from the cooling remains of the Big Bang. The light left those galaxies before our planet even existed, before our sun had begun to burn. In a single frame, Webb showed thousands of worlds, each filled with billions of suns, each one with its own history, its own silence, its own questions. To look at that image is to feel the passage of time not as something we move through, but as something that moves through us. The colors are gentle, the shapes soft and distant, but the meaning is enormous. We are seeing light older than life itself, and yet Webb does not replace Hubble. They are partners, not rivals. Hubble sees invisible light catching the luminous blues and golds of stars as we would see them with our eyes. Webb sees in the infrared, capturing the heat that reveals what lies behind, beneath, and before. Together they form a bridge. Two perspectives on the same vast mystery, one seeing the glow, the other seeing the hidden source. Their partnership reminds us that understanding often requires two kinds of vision, one for what is seen and one for what is unseen. Webb's mission extends far beyond the art of its images. Its instruments study the chemistry of distant worlds, searching for the faint signatures of life in alien skies. By splitting light into spectra, Webb can read the fingerprints of molecules, water, carbon dioxide, methane, etched in the light of stars as it filters through planetary atmospheres. Each tiny dip in brightness tells a story about temperature, composition, and possibility. When Webb studies exoplanets, it does not look for life directly. It looks for the conditions that might cradle it, for warmth, for balance, for the chemistry of breath. It has already examined worlds like WASP 39b, a giant planet orbiting so close to its star that its day side glows hotter than molten rock. In that light, Webb found traces of carbon dioxide, the first clear detection of its kind beyond our solar system. A small, quiet confirmation that we are reading the language of other skies. Later, Webb turned its gaze toward smaller rocky planets. TRAPPIST-1, a system of 7 worlds circling a cool red star, some possibly warm enough for liquid water. There, Webb searches for whispers, the faint, uneven signals that might mean clouds, oceans, or even weather. Nothing conclusive yet, but every spectrum, every pixel of data is a step closer to knowing whether the universe breathes beyond us. Its instruments also listen to the echoes of the Big Bang. In the faint red shift of ancient galaxies, it measures how quickly the universe expands, how matter once clustered, how the first light escaped from the cosmic fog that once filled everything. Through these measurements, Webb helps us refine the story of our origin, not as myth or metaphor, but as an unfolding sequence of light, temperature, and time. Sometimes Webb's images are so beautiful that people forget they are data. Every shade of amber, cobalt, and rose is a wavelength chosen to represent a temperature, a pattern, a distance. Science rendered as stillness, art made of understanding. If you were floating beside the telescope, you would see something fragile. Its golden mirrors spread like petals. Its silver sun shield stretched beneath it to block the heat of the sun, the earth, and the moon. The shield is thinner than a human hair, yet it protects the instruments from temperatures that would melt metal. On one side, the sunlight burns at over 100 degrees Celsius. On the other, the instruments rest in shadow, chilled to -230. Between them, the difference keeps Webb's sensors still enough to read the faintest whispers of ancient light. The telescope orbits a region called L2, the second Lagrange point, a place where the gravity of the Earth and Sun balance so that Webb can follow our planet's orbit while staying always in shadow. It is a place of quiet stability, a pocket of balance in the endless motion of the solar system. From there, Webb's mirrors never blink. They watch the universe unfold with no sunrise, no sunset, only the slow turning of eternity. Each observation Webb makes is an act of memory. Light from the earliest galaxies travels billions of years before it meets the telescope's mirrors. When we see those galaxies, we do not see them as they are, but as they were when the universe was young, their light stretched and cooled by the expansion of space. It means that when you look at a Webb image, you are not looking out but back. Every pixel is a window through time. That thought changes how we think of distance. Space and time blur together. The farther away something is, the older its light. The deeper Webb looks, the closer it comes to the beginning, the dawn of everything. At its limits, the telescope approaches what astronomers call the cosmic dawn, the moment when the first stars ignited and ended the long dark age of hydrogen. Before that, the universe was formless and opaque, filled with neutral atoms that scattered light. When the first stars lit, their radiation broke that darkness apart, and the cosmos became transparent. Webb's deepest mission is to find those first lights, the moment when the universe first saw itself. It has already glimpsed galaxies that formed less than 300 million years after the Big Bang, small irregular clusters of stars, their light stretched into ruby tones by distance. Some appear surprisingly mature, suggesting that galaxies formed earlier and faster than we once believed. Others look like fragile sparks, the first fires in an endless night. Each discovery redefines our timelines, reminds us that even cosmic history begins with uncertainty. And through all of it, through the calibrations, the alignments, the images that drift home across the void, there is a quiet human truth. This telescope, this golden mirror sailing through nothingness, exists because we wanted to know. We wanted to see where light begins and where it fades. We built it not to conquer the dark, but to listen to it. Every image it sends is both science and prayer, a map of what is real and a reflection of how deeply we wish to understand. You can imagine Webb now moving slowly in its orbit, folded into the steady rhythm of sunlight and shadow. Its instruments breathe in heat from stars. Its sensors record time itself, and somewhere deep inside its memory, a beam of light that began before our world existed finally finds a home. The James Webb Space Telescope does not end the story of exploration. It opens the next chapter. Because as it looks deeper into the universe, Hubble still watches nearby, capturing the visible light, the familiar colors. Together, they create a duet, the seen and the unseen, the present and the ancient. Through them, NASA has given us a mirror not only of the cosmos, but of ourselves, curious, small, persistent, and capable of wonder beyond reason. And as you rest here, you are part of that same quiet curiosity. The same atoms that once burned in the stars, Webb studies now breathe within you. You are made of starlight looking back at its own beginning. Let your breath match the rhythm of that thought. Slow, calm, infinite. For the universe is still expanding, and you are expanding with it a small, luminous thought in a galaxy's dream. The story of the James Webb Space Telescope begins in gold and silence. But before Webb ever opened its eyes, another mirror watched the sky from closer to home. It orbited just above the veil of Earth's atmosphere, turning slowly, patiently, in a rhythm that has lasted for more than 3 decades. This was the Hubble Space Telescope, the elder eye, the bridge between our blue world and the depths beyond it. It circles only 550 kilometers above Earth, yet its gaze has reached across billions of light years, across the full arc of cosmic history that light allows. Where Webb listens in infrared whispers, Hubble speaks in the bright colors of visible light, the light our eyes were shaped to see. And it was Hubble that first showed us what it meant to look at the universe not as a backdrop, but as a living, evolving creation, a place still becoming itself. When Hubble was launched in 1990, it carried not only lenses and instruments, but the weight of human hope. For the first time, a telescope would see from beyond the blur of the atmosphere, free from the shimmer of air and weather, seeing stars and galaxies in their true clarity. But when the first images returned, they were not sharp. They were blurred. The main mirror had been shaped just slightly wrong, too subtle for human eyes to notice, but enough to scatter the light of the universe. It was for a moment a symbol of our imperfection, how even our most careful designs can falter. But in that mistake, there was also beauty, a reminder that discovery requires patience, and that vision often comes after correction. 3 years later, astronauts from NASA boarded the Space Shuttle Endeavour and met the telescope face to face in orbit. They repaired it by hand, installing new optics that acted like glasses to focus the wandering light. When Hubble opened its eyes again, the universe came into focus. Galaxies sharpened. Nebulae bloomed. The blur became revelation. From that moment on, Hubble began to tell the story of the cosmos in color and detail no one had seen before. It revealed the lives of stars, the geometry of galaxies, and the quiet evidence of forces we could not see at all. Every image was a window into the endless, but also a mirror reflecting the persistence of human wonder. One of Hubble's first breathtaking portraits was of the Butterfly Nebula, a fragile and fiery cloud spreading its wings in the constellation Scorpius. It is the remains of a giant star's last breath, a death performed in beauty. At its center lies a white dwarf, the dense heart left behind after the star shed its outer layers. From that heart stream jets of gas so hot they glow with ultraviolet light. To the eye, the nebula looks like a pair of luminous wings made of smoke and fire. Through Hubble's lenses, the universe shows us that endings can shine as brightly as beginnings. Another of Hubble's discoveries lay within the Pismus 24 cluster, where enormous blue stars gather in a single bloom of light. Each of those suns is more than 100 times the mass of our own, their surfaces thousands of degrees hotter. Their lifetimes are short, mere millions of years. But during that time they flood their surroundings with radiation strong enough to sculpt the nebula around them. Hubble revealed their edges, their burning halos, and the filaments of gas stretching like silk between the stars. In their light, we see the raw intensity of creation. And in the Sombrero Galaxy, Hubble showed us symmetry, a galaxy that seems perfectly poised between light and shadow. It is a spiral seen from the side, its central bulge glowing like a pearl surrounded by a thin, flat ring of dust and stars. From Earth it looks small, but it spans 50,000 light-years, a vast system of suns orbiting a dark, massive heart. Hubble captured its fine edge, the bright halo that softens into the black of space, a cosmic silhouette, both calm and immense. Hubble has seen collisions too, galaxies pulling at each other, stars forming from their shared dust. In Stephan's quintet, the same group Webb later revisited. Hubble first showed the tangled arms of galaxies mid-dance, the soft trails of starlight they left behind. It also revealed entire clusters like the Coma cluster, where thousands of galaxies gather in one enormous region of space. Within that cluster, astronomers first inferred the existence of dark matter, a presence that cannot be seen, but whose gravity holds galaxies together. It was a discovery not of light, but of the invisible weight beneath it. Hubble's reach is not limited to the luminous. It also touches the fragile and strange. It saw the NGC 1052 DF2 galaxy, a faint ghostly island of stars that seemed to lack dark matter almost entirely. It defied expectation. If galaxies are bound by the gravity of dark matter, how could this one exist without it? The answer is still uncertain. Maybe dark matter was stripped away. Maybe the galaxy formed differently. But the image reminds us that even in cosmic order, there is mystery, small, quiet exceptions that reshape our understanding of everything. In the early 2000s, Hubble began a bold experiment to point at what looked like nothing. A small patch of sky no larger than a grain of sand held at arm's length was chosen for a long exposure, a deep stare into apparent emptiness. Astronomers called it the Hubble Deep Field. For 10 days, the telescope gathered light from that single patch. When the image was finally processed, it revealed thousands of galaxies, swirls, spirals, ellipses, smudges of color, each one a universe of stars. The emptiness had been full all along. That discovery changed how we see the night. It taught us that darkness is not absence, but distance, and that even in the smallest square of sky, the infinite is waiting. Later, Hubble would repeat the experiment, producing the ultra-deep field and extreme deep field, each deeper than the last, each pushing the boundary of what we can see. Those images are not just photographs. They are time itself stretched thin across billions of years. Sometimes Hubble turned its gaze closer to home, to the delicate structure of our own galaxy. It watched the remnants of ancient stars like the Palomar 12 cluster, a collection of old stars orbiting the Milky Way. But its motion was peculiar. Its orbit didn't match our galaxy's pattern. Astronomers realized it had been stolen a cluster captured from the Sagittarius dwarf galaxy long ago. Even galaxies, it seems, have histories of migration and memory. And then there were the individuals, the loneliest lights. Through the lens of Hubble, we saw stars so distant that their light had crossed nearly the entire observable universe. One of them, named Icarus, shone from 9 billion light-years away, its glow magnified by the bending of space itself, a gravitational lens. Later, Hubble found another Earendel, whose light had traveled for 12.9 billion years, perhaps the oldest single star ever observed. These discoveries stretched the meaning of distance, showing that even one star's light can carry the memory of cosmic dawn. At the edge of all this, Hubble glimpsed the HD-1 galaxy, the farthest known object ever seen, shining from a time when the universe was only 300 million years old. It is faint, ancient, and small, but in its glow, we see the first galaxies assembling, the first structure forming from the smooth background of radiation. It is quite literally the light of the beginning. Through these images and more, Hubble has given shape to the story of expansion, the gentle outward breathing of the universe since the Big Bang. By comparing the light from nearby and distant galaxies, scientists measure how quickly space itself stretches. The light is red-shifted, its waves stretched longer as it travels. And from those measurements, we learn how the universe grows. We also find a quiet tension. The rate of expansion measured by Hubble is slightly faster than the one predicted by other cosmic data. This mismatch, called the Hubble tension, might mean our understanding of the universe's earliest physics is incomplete. Even after decades, Hubble still offers more questions than answers. But that is what makes its vision so alive. Each observation hums with uncertainty, with the soft sound of something just beyond reach. If you could see Hubble as it moves a silver cylinder turning against the curve of Earth, you might not think it powerful. It looks small, almost fragile, but in its steady motion lies persistence. For more than 30 years it has endured sunlight, shadow micrometeoroids, and time itself. Astronauts have visited 5 times to repair and upgrade it, each mission a reminder that exploration is an act of care. We build machines to look outward, but we sustain them through human hands. Even now, as Webb explores farther in infrared, Hubble remains our bright companion. It watches the nearer galaxies, the colorful nebulae, the living stars. Together, they form a continuum, the visible and the invisible, the new and the experienced, the twin eyes of human curiosity. Sometimes when Webb sends back an image of a distant galaxy, astronomers pair it with an older one from Hubble. Side by side, they form a harmony, the glowing youth of the stars in visible light and the soft veiled structure in infrared. It is like hearing 2 notes of the same song, one high and one low together, making a chord that resonates across time. From this union comes a deeper picture, a cosmos that is not static but layered like memory itself. Every wavelength adds a new color to the truth. And so, the Hubble Space Telescope is not only a tool, it is a witness. It has seen the rise and fall of stars, the first proof of dark matter, the faint edge of the observable universe. It has shown us that we live not at the center of creation, but within its current, carried by time, like dust within light. Even after all these years, Hubble continues to orbit above the quiet side of Earth, passing over oceans, deserts, and cities, glowing faintly below. Each orbit takes about 95 minutes daylight and night, repeating endlessly. Each sunrise over the curve of the planet casts gold across its mirrors. Each sunset leaves it in shadow, alone with the stars. And from that place of rhythm and solitude, it keeps sending us visions of the endless images that remind us how vast and yet how delicate the universe truly is. The James Webb Space Telescope may peer farther, but Hubble remains our teacher of light, the one that taught us how to look. Together, they form a conversation between generations, each refining what the other begins. Webb's golden eyes reveal the hidden beginnings, while Hubble's silver gaze preserves the luminous middle. One listens to the whisper of heat, the other to the brightness of color. Together they describe the same song in 2 harmonies, a duet between light and time. And when you close your eyes tonight, you might imagine them both suspended above the quiet curve of the Earth, looking outward through eternity, each mirror reflecting not just the universe, but the quiet persistence of the human heart. The edge of the universe, it turns out, is not a wall, but a direction, a way of looking that never ends. The story of the universe has carried us outward through Webb's golden eyes, through Hubble's long, steady gaze to the edge of what we can see across billions of light years. But now let us turn gently closer. Not toward the beginning of time, but toward the cold boundary of our own solar home. Beyond the orbit of Neptune, beyond the faint whisper of sunlight, where the warmth of our star fades to silence, lies a region like a frozen memory, a halo of ice and shadow called the Kuiper Belt. It is not a place of blazing galaxies or cosmic fire, but a slow, glittering sea of ancient things, the remnants of our solar system's creation, still drifting in darkness, unchanged for billions of years. It circles the sun in quiet persistence, a disk of icy bodies stretching perhaps 50 times farther than the Earth. Each world here moves slowly, their orbits elongated and tilted, their surfaces bright with frost and methane snow. They are the leftovers of creation, the pieces that never gathered into planets. They remain patient, silent, pristine, a cosmic archive of the time when everything was still forming. If you picture our solar system, you might imagine it as a family of planets orbiting a central sun. Mercury, Venus, Earth. Mars, then the great gas giants Jupiter and Saturn, and finally Uranus and Neptune spinning in blue shadows at the edge. But beyond Neptune's soft ring of light, there is more. A whole other realm begins the Kuiper Belt, named after astronomer Gerard Kuiper, who suspected that such a region must exist. It is the outer cousin of the asteroid belt, but so different in mood and matter. The asteroid belt is rocky and sunlit, its fragments warm and dry, the remains of an unfinished planet between Mars and Jupiter. The Kuiper Belt, by contrast, is cold and slow. Its worlds made not of stone, but of ice, frozen nitrogen, methane, ammonia, and water, locked together in the dark. The two belts are like two verses of the same poem, one written in sunlight, the other in starlight's afterglow. Among the scattered worlds of the Kuiper Belt, one name stands above the rest: Pluto. Once called the 9th planet, now known as one of many large icy bodies at the solar frontier. It drifts through a slow orbit that takes 248 years to circle the Sun, sometimes closer than Neptune, sometimes far beyond. When the sunlight reaches Pluto, it is weak, so faint that the daylight there is no brighter than twilight on Earth. Yet it shines just enough to reveal a surface of astonishing complexity. For decades, Pluto was nothing more than a blur of light in telescopes. We could only imagine what it looked like. Then, in 2015, a small spacecraft named New Horizons arrived. After traveling for nearly a decade through the deep quiet of space, it finally swept past Pluto and looked upon it for the first time. The images it sent home changed everything. Pluto was no frozen wasteland. It was alive in its own way, its surface carved by glaciers of nitrogen, its plains shimmering with frost, its heart-shaped region called Sputnik Planitia, stretching like a soft scar of white and rose. That heart became a symbol not just of the planet itself, but of our connection to it, a distant world with a quiet pulse. Scientists believe that Sputnik Planitia was formed by a vast impact early in Pluto's history, a collision that carved a basin hundreds of miles wide. Over time, the hollow filled with frozen gases which may still shift and flow like glaciers today. Even here, 4.5 billion kilometers from the Sun, motion continues. Even in the coldest silence, change endures. Pluto's largest moon, Charon, orbits so close that the two worlds are locked in a perpetual dance. They face each other always, a binary pair turning together through the dark. Charon is half the size of Pluto, its surface marked by canyons and ancient ice. Some believe it once held a subsurface ocean, now frozen solid but still recorded in its scars. The boundary between them is not that of planet and moon, but of two equal companions holding each other in quiet orbit forever, linked by gravity and time. Beyond Pluto lie other large worlds, each with its own secrets, its own rhythm of light. Eris, slightly smaller than Pluto, is one of the brightest objects in the solar system. Its icy surface reflects nearly all the sunlight that reaches it, a mirror drifting in the dark. It takes 557 years to complete one orbit around the Sun. For half that time, it wanders far beyond Pluto's path, so distant that the Sun becomes only the brightest star in the sky. Then there is Makemake, a reddish world covered in frozen methane. Its name, drawn from the mythology of Easter Island, evokes creation and fertility, an echo of life in a place where temperatures plunge below -200 degrees Celsius. And Haumea, an elongated world shaped like an egg spinning so fast that it bulges at the equator. Its rapid rotation completes a full spin in just 4 hours. Around it orbit 2 small moons, and even a ring of icy particles, a miniature solar system of its own. Each of these worlds, though smaller than Earth's moon, adds another note to the quiet symphony of the Kuiper Belt. They are reminders that creation was never simple, never uniform. Even at the edges of sunlight, diversity blooms worlds that are spherical, flattened, tilted, or ringed, each one a frozen thought left over from the dawn of the sun. The Kuiper Belt is also the birthplace of comets. Not the long-period comets that visit us from the far Oort cloud, but the shorter ones that appear every few decades or centuries, their orbits tracing elegant ellipses between the planets. When one of these icy travelers is nudged inward perhaps by the gravity of Neptune or a passing star, it begins to fall toward the sun. As it warms, its ice vaporizes, forming the luminous tail we see from Earth. Each comet is a messenger from the belt, a visitor carrying the chemistry of creation into our skies. Some comets return regularly: Halley's Comet, Encke's Comet Tempel-Tuttle, each one shedding a little more with every visit, until one day it will fade completely into dust. Their orbits are stories written in ice stories that began in the cold and end in light. When the New Horizons probe left Pluto behind, it continued deeper into the belt. 4 years later, in 2019, it encountered another object, a small snowman-shaped world now known as Arrokoth. Arrokoth is made of 2 lobes, gently fused together, each about 20 kilometers wide. Unlike the violence of planetary collisions, its formation was serene. The 2 bodies likely drifted together slowly, touching and merging without shattering. This discovery reshaped our understanding of how planets form. Perhaps the early solar system was not a battlefield, but a gathering worlds coming together in quiet patience, settling into shape as snowflakes do, softly, silently. Arrokoth's surface is reddish, its color the result of sunlight transforming complex molecules over billions of years. Its craters are few. Its landscape preserved a fossil of the time before the planets matured. Through it, we glimpse how the solar system began not with chaos, but with calm. The Kuiper Belt also gives us insight into how planetary systems evolve. The distribution of its objects tells a story of migration. Long ago, the giant planets Jupiter, Saturn, Uranus, and Neptune did not form where they are now. They drifted. As Neptune moved outward, its gravity scattered icy bodies into distant orbits, creating the structure of the belt as we see it today. Some objects were captured in stable resonances, their orbits synchronized with Neptune's motion, like dancers moving in time with a silent beat. Others were thrown into elongated paths that carry them toward the edge of interstellar space. Even now, those frozen travelers continue their slow ballet following patterns older than humanity itself. Their orbits are the handwriting of creation's soft loops of gravity drawn across the fabric of time. If you were to stand on one of these distant worlds, the sun would hang in the sky as a tiny blinding star, far smaller than the moon appears to us. The light would be faint, barely enough to cast a shadow. The stars around you would be steady and sharp, no twinkle, no shimmer, for there is no air to disturb them. The silence would be absolute. You could stretch out your hand and feel nothing, only the idea of cold. And yet, in that emptiness, you would be standing amid the most ancient materials in the solar system, the first ices, the first stones, the ingredients from which all planets, all oceans, and even life itself were born. The Kuiper Belt is in this way a kind of time capsule, a place where the clock of formation stopped. Everything closer to the sun changed and melted and reformed. But here, nothing rushed. The cold preserved what was. To study it is to study the past, not as a memory, but as a living landscape. And there is a deeper poetry in that. For just as Webb looks back through billions of years of light and Hubble reveals galaxies at the edge of time, the Kuiper Belt lets us look backward through our own story, the local version of the same cosmic theme. The vast and the intimate mirror each other. The same processes that built galaxies also built these small frozen worlds. Gravity gathers. Matter cools. Light emerges. Time continues. The scale changes, but the pattern is the same. Every orbit, every drift of dust is a reflection of the universe's larger rhythm: creation, balance, decay, and renewal. Even here in the cold, silence, that rhythm hums softly beneath the ice. NASA's exploration of this region is still young. New Horizons continues to send data from the outer dark, its signal faint but steady. It listens for the whisper of more distant worlds, and someday may pass beyond the Kuiper Belt, entirely entering the deep emptiness where the sun's influence fades, a prelude to the journeys of Voyager, which await us in the next chapter. For now, though, imagine the spacecraft still turning its antenna aimed homeward, sending back a trickle of light, a heartbeat of data across billions of kilometers. The light takes hours to reach us, but it does arrive, proof that even at the edge of the sun's light, our curiosity endures. The Kuiper Belt reminds us that the edge is never truly an end. It is simply the beginning of something colder, quieter, and unknown. Beyond it, the sun's wind slows. Space begins to belong not to our star, but to the galaxy itself. But here within this ring of ancient worlds, we still find the imprint of our origin. We find the patience of ice, the endurance of orbit, and the silence that gave birth to everything we know. When you think of the Kuiper Belt, you might imagine it as distant and unreachable, but in another sense, it is deeply familiar. The atoms in your body, the oxygen in your breath, the carbon in your cells once drifted through the same disk of dust and gas that gave rise to those icy worlds. The belt is not beyond us. It is part of the same story that shaped us. And so, even as we look outward from Earth's warm glow, our gaze toward the Kuiper Belt is also a gaze inward toward the quiet beginning of everything we are. The planets circle the sun. The Kuiper Belt encircles them all. And around that, the stars of the Milky Way continue to spin, turning slowly through the dark. Every orbit echoes another. Every world drifts in rhythm with the rest. It is a kind of cosmic breathing, steady, eternal, serene. And perhaps that is the lesson of this distant ring of ice, that creation is not a single event, but an ongoing stillness, a balance of movement and rest. Each world in the belt, each faint glimmer of frost, is a frozen thought of the solar system itself whispering softly across the centuries. As the light from those worlds takes hours to reach us, so too does our understanding take time. But patience, like gravity, always brings things together. The Kuiper belt fades slowly into distance, its icy orbits stretching farther, its faint sunlight dissolving into starlight. Beyond that soft ring, there is no longer a border, only a gradual quieting. The warmth of the sun grows weaker. Its magnetic breath begins to falter. And beyond that invisible edge, interstellar space, begins the domain of the galaxy itself. It is there, between sunlight and starlight, that two travelers continue their journey. Two small spacecraft launched long ago still whisper home through the silence. They are Voyager 1 and Voyager 2, the oldest and most distant messengers humanity has ever sent. Their story begins not in darkness, but in hope, a dream of exploration born beneath the blue skies of Earth. In 1977, NASA launched the two Voyagers to take advantage of a rare alignment of the outer planets. Once every 176 years, the orbits of Jupiter, Saturn, Uranus, and Neptune line up just so, allowing one spacecraft to visit them in sequence, each planet's gravity flinging it onward to the next. This grand tour would take 12 years, a journey across 4 billion miles. But what followed has lasted far longer. Each Voyager is no larger than a small car, its body wrapped in gold foil for warmth, its antenna shaped like a white dish pointed eternally toward Earth. Beneath that dish lies a record, a golden phonograph etched with sounds and images chosen to represent life on our world. Greetings in dozens of languages, the laughter of children, the song of a whale, the heartbeat of a woman. If someday another intelligence finds it, they will hear what we once were fragile, curious, reaching outward. Even before they left the solar system, the Voyagers transformed our view of it. They revealed the outer planets not as distant dots, but as living worlds. Jupiter came first, a giant of storms and color. Voyager 1 arrived in 1979, its cameras capturing the first close images of the Great Red Spot, a hurricane 3 times wider than Earth, swirling for centuries in Jupiter's atmosphere. Lightning flickered within its clouds, and faint rings circled the planet like whispers of dust. But the true revelation came from its moons. Io, fiery restless, erupted with sulfur volcanoes, the first active volcanoes ever seen beyond Earth. Plumes rose hundreds of kilometers high, falling back as frozen rain across its surface. Europa, smooth and pale, showed no craters, but long cracked lines, as if its crust of ice floated upon an ocean below. For the first time, we understood that there might be liquid water beyond the warmth of the sun, and with it, the possibility of life. Ganymede, largest of all moons, was revealed as a world in its own right, its surface etched with ridges and grooves. And Callisto, battered by eons of impacts, shimmered like an ancient mosaic of ice and stone. The Jovian system became a miniature solar system, a harmony of contrasts, fire and ice chaos, and calm, each moon a reflection of creation's endless variety. From Jupiter, gravity flung the Voyagers toward Saturn, a place of order and elegance. Where Jupiter was turbulent, Saturn was serene. Its golden clouds banded and smooth its rings, spread like light frozen in motion. Before Voyager, we thought those rings were solid. Afterward, we learned they were made of countless particles, bits of ice and rock, each orbiting with delicate precision. The spacecraft flew through the plane of the rings, passing just above their edge. It saw gaps and waves sculpted by gravity moons, shepherding the edges like silent sentinels. Voyager also discovered Titan's mystery, a world wrapped in a thick orange haze. Its surface was hidden, but its atmosphere, rich in nitrogen and methane, reminded scientists of Earth's in its earliest days. It was a hint that Titan might one day reveal lakes, rivers, and perhaps chemistry akin to life's first breath. As Voyager 1 completed its flyby, its trajectory carried it away from the ecliptic, out of the plane of the planets, on a course that would one day lead into interstellar space. Voyager 2, meanwhile, continued onward, its path still curving through the outer system. In 1986, Voyager 2 reached Uranus, the first spacecraft ever to visit that tilted, mysterious world. Uranus spins on its side, its axis tilted 98 degrees, so its poles lie where its equator should be. For half of its long year, one hemisphere faces the sun in constant daylight, while the other remains in darkness. Voyager's instruments found an atmosphere of hydrogen and helium tinged with methane, giving the planet its aquamarine hue. Its magnetic field was strangely misaligned, not centered, but skewed, as if twisted by some ancient event. The spacecraft discovered 11 new moons, some only a few dozen kilometers wide, and faint rings, like ghostly shadows encircling the planet. 3 years later came Neptune, the last of the giants, deep blue and distant. Voyager 2 arrived in 1989, capturing images of the fastest winds in the solar system, reaching 2,000 kilometers per hour, driving storms across its atmosphere in dark ovals and streaks. One of them, the Great Dark Spot, appeared and vanished within years, a reminder that, even at the edge of sunlight, weather never sleeps. Neptune's moon, Triton, was perhaps the greatest surprise. It moved in the opposite direction of Neptune's rotation, a captured body perhaps once part of the Kuiper Belt. Its surface was pale pink, scored with frozen nitrogen geysers erupting hundreds of meters high. Even here in the deep, cold motion continued. Voyager's cameras recorded them faintly thin plumes casting shadows on the ice. Beneath that surface, scientists now believe there may be another hidden ocean, a familiar theme whispered through the solar system's outer moons. By the time Voyager 2 left Neptune behind, its twin had already traveled beyond Pluto's orbit. Both spacecraft were leaving the realm of planets, crossing into the solar system's vast frontier, the heliosphere, where the sun's charged particles flow outward until they meet the winds of interstellar space. There, the solar wind slows and bends. At its outer edge, the heliopause, the influence of the sun, fades to nothing. Beyond lies the true galaxy, the thin sea of atoms that fills the space between the stars. Voyager 1 crossed that boundary in 2012, becoming the first human-made object to enter interstellar space. Voyager 2 followed in 2018. Neither saw a sudden transition. There is no wall, no light, only a slow change in the rhythm of charged particles, the whisper of one wind giving way to another. They now drift more than 20 billion kilometers from home. It takes over 22 hours for their faint radio signals to reach Earth traveling at the speed of light. And yet those signals still come tiny ripples across the void carrying data about a place no human will ever touch. The information they send is sparse but precious. Each spacecraft measures the density of particles, the strength of magnetic fields, and the direction of cosmic rays, the charged fragments of stars that explode far away. From these clues, scientists have learned how the heliosphere protects us, how it bends under the pressure of the galaxy's winds. Voyager's readings show that space is not empty, but filled with a low hum of plasma, a background vibration that sings softly through infinity. In 2020, Voyager 1 detected a persistent tone, a faint constant note at a frequency of about 3 kilohertz. It was the sound of interstellar gas vibrating under cosmic radiation. For the first time, we were hearing the music of the space between stars. The Voyager's instruments have aged their power, fading slowly. Each spacecraft runs on a small nuclear generator, the heat from decaying plutonium turning into electricity. Every year that power diminishes. To conserve energy, NASA engineers have turned off one instrument after another, keeping only the most vital systems alive. Still, they endure. Their hearts still beat, their antennas still whisper home. By 2025 or so, their power may finally run out. Their signals will fade into static. After that, they will drift forever silent but intact, carrying the golden records across the Milky Way. In time, they will pass other stars. Voyager 1 will approach the red dwarf Gliese 445 in about 40,000 years. Voyager 2 will pass near Ross 248 a few millennia later. By then, Earth will have changed beyond recognition. Our languages perhaps vanished, our sun itself grown older. And yet, those small emissaries will still move onward, each carrying a portrait of our species, the breath of oceans, the pulse of life, the music of curiosity. There is something deeply human in their endurance. They were built for 5 years of work. They have lasted almost 50. They were sent to study planets, but have become time capsules, each one tracing a path into eternity. Their journey mirrors our own impulse to know, to reach, to understand, to continue. You can imagine them now 2 points of light, invisible even to telescopes, sailing through a black sea without wind or sound. Their paths diverge like twin comets, one north of the sun's plane, one south, each drifting in endless night. Around them the stars wheel slowly, unaware that something from one of them is moving among their light. Perhaps that is what makes their story so moving. They remind us that even the smallest creation, if sent with intention, can travel beyond all expectation. Their messages return to Earth through the Deep Space Network giant radio dishes scattered across the planet in California, Spain, and Australia. Each antenna listens for a whisper, weaker than a watch battery's flicker, spread across billions of kilometers. When the signal arrives, it is transformed, a faint murmur, into numbers, numbers into meaning, meaning into knowledge. In that act, our planet and those distant travelers remain connected by invisible threads of light. Each time we hear from them, we are reminded that distance is not absence. Even after decades, communication endures. A spark from one world still reaches another. And then there is the golden record, the Voyager's final gift, their message for anyone or anything that might one day find them. On its surface are engraved instructions for how to play it, how to read the encoded images and sounds. Inside are greetings from Earth's many languages. Hello from the children of planet Earth. There is the sound of rain, the cry of a baby, the chirping of crickets in a summer field, a heartbeat, a kiss. Etched into the record's surface is a map, a diagram of our sun's location relative to 14 pulsars, and a sketch of the hydrogen atom's frequency. It is simple mathematical universal, a way of saying, this is where we came from. This is what we are. No one knows if it will ever be found. It may drift forever in the dark, its grooves never touched, its message never heard. But that is not the point. The record is not a communication. It is an offering, a gesture of hope cast into eternity. And perhaps, even if it remains unheard, its purpose is fulfilled. Because in making it, we declared that our small, brief lives belong to something larger. Now the Voyagers move in a realm where sunlight never reaches. They are beyond the heliosphere, beyond the reach of the planets, beyond even the Kuiper Belt. They drift through interstellar space, not toward any destination, but into the vast quiet that connects all things. The same quiet that fills the gaps between stars. The same quiet that fills the space between your breaths. It is the same silence Webb listens through, and the same stillness Hubble captured in light. The Voyagers do not look back or forward. They simply continue. And in their endless motion, they echo the rhythm of the universe itself, expanding, drifting, becoming. They remind us that the edge of our solar system is not an ending, but a threshold. Beyond it lies the galaxy, and beyond the galaxy, a greater ocean still. The Voyagers are our first steps into that sea. Some nights when you look up, you can imagine them there, not visible, not even in imagination as points of light, but as ideas moving quietly beyond the stars you can see. Each second they travel farther, their speed constant, their direction fixed, their silence infinite. They are proof that even the smallest human creation can endure beyond the life of its makers. They are proof that curiosity is stronger than distance, stronger than time. And so, while Hubble and Webb gaze backward in time, Voyager 1 and 2 travel forward in space, outward into the future, carrying the faint music of our world to the farthest edge of the unknown. The Voyagers drift onward, beyond the glow of the sun, beyond the rhythm of planets. Their golden records turn slowly in darkness, carrying songs no one may ever hear. And yet, their motion continues, a silent promise that exploration never truly ends. From their small paths through interstellar night, our gaze now turns outward again, far beyond the edge of the solar wind, past every galaxy Hubble and Webb have ever seen. We arrive at a question too large for sight, too soft for measurement. How big is the universe? Or perhaps is it even bounded at all? The question does not demand an answer. It invites reflection. Because to speak of the edge is to imagine that there is a border, a final line, a place where something ends and something else begins. But the universe is not a shape we can hold. It is a geometry of space and time itself, a vast and continuous unfolding. We move through it as fish move through the sea, never sensing its edge, only the current and the deep. Astronomers describe three possible shapes for the cosmos: flat, spherical, and hyperbolic. Each is a way of thinking about the same mystery: how space curves under the weight of everything that exists. If the universe is flat, its geometry obeys simple rules. Parallel lines never meet. Light travels in straight paths. You could fly forward forever and never return to your starting point. A flat universe extends infinitely, without boundary, without repetition. A cosmic plane stretching without end in every direction. If the universe is spherical, then it is curved like the surface of a ball. Travel far enough in one direction and you would circle back to where you began. There is no edge, only continuity. It is finite, yet unbounded, a shape that folds in on itself like a great cosmic loop. If the universe is hyperbolic, its curvature bends outward like the surface of a saddle or a wave. In such a universe, parallel lines diverge forever. Space expands faster the farther you travel, and the distance between galaxies grows without limit. It is infinite and open, a vast sea that never repeats its horizon. Einstein's theory of general relativity tells us that mass and energy bend space-time itself. Galaxies, clusters, and dark matter curve the universe around them as though the fabric of space were soft and pliant. That curvature gives rise to gravity, not as a force, but as the shape of motion itself. Imagine a marble rolling across a stretched sheet of fabric. Wherever there is a weight, the marble's path bends toward it. In the same way, planets orbit stars. Stars gather into galaxies, and galaxies cluster in invisible threads woven by gravity across the dark. This is the architecture of existence, not built, but shaped. The same principle applies on cosmic scales. The total amount of matter and energy, including the unseen dark energy that drives expansion, determines the universe's curvature. Too much matter, and the universe curves inward, eventually collapsing under its own weight. Too little, and it curves outward, expanding forever. Between those two extremes lies balance, a universe perfectly flat, expanding endlessly, but at a rate just slow enough to never tear apart. All the evidence we have so far from the cosmic microwave background, from galaxy distributions, from the bending of ancient light, suggests that our universe is flat. Not exactly, but astonishingly close. So close that its curvature, if it exists at all, is too subtle to measure. This means the universe could be infinite, or so vast that it may as well be. The light from the farthest galaxies we see has traveled for 13.8 billion years, yet those galaxies are now far farther away, carried by the expansion of space. Our observable universe, the portion from which light has had time to reach us, is about 93 billion light-years across. Beyond that, the rest continues unseen, perhaps without end. But infinity is not a number. It is not bigger than anything. It is a concept, the idea that there is no final limit, that existence extends beyond what can ever be counted. To call the universe infinite is to admit that it cannot be enclosed, not by space, not by time, not even by imagination. And yet there is another possibility, that the universe might be finite but unbounded, a shape without edge, like the surface of a sphere in higher dimensions. You could travel forever and never find an end, yet the total volume would still be limited. In this way, Infinity and finiteness are not opposites, but reflections of the same idea. Infinity is not endless size, it is endless connection. If you look far enough, you might see yourself from behind light looping through curved space, returning after billions of years. The universe could repeat itself like a cosmic hall of mirrors, each reflection a different era of the same whole. Perhaps distant galaxies we see today are echoes of our own, their light bent by geometry and time. In cosmology, this mystery leads to humility. Because whatever its shape, the universe appears perfectly tuned, its energy, matter, and curvature balanced to an astonishing degree. Had it been slightly denser, it would have collapsed soon after its birth. Had it been lighter, it would have expanded too fast for galaxies, stars, or life to form. Some call this balance coincidence. Others call it necessity. But perhaps it is simply the nature of being to exist at the delicate point between collapse and dispersal, between too much and too little. You might think of it as the rhythm of breath. The universe inhales in gravity, drawing matter together. It exhales in expansion, pushing galaxies apart. And somewhere in between those motions, we exist a single instant between inhale and exhale, a moment of awareness within infinity. Even the word infinite carries a quiet paradox. If something has no end, then it has no center either. There is no middle of the universe, no place from which everything else expands. Every point is central. Everywhere is equally far from everywhere else. This means you are at the center, and so is every other being, every atom, every star. The universe expands not into space, but as space. There is no outside, only more of within. From the viewpoint of the cosmos, edges do not exist, only horizons. A horizon is not a boundary. It is a limit of perception, a place beyond which light has not yet arrived. As time passes, that horizon grows, and more of the universe comes into view. But what lies beyond it remains real, even if unseen. So when we ask, is the universe larger than infinity? The question becomes poetic rather than literal. We are really asking, can there be something beyond what never ends? And the answer, softly, is that infinity is not a place to go. It is a way of being, There is another mystery hidden here, the multiverse hypothesis. If space-time can inflate once, as it did in the Big Bang, perhaps it can do so again and again in different regions beyond our cosmic horizon. Each bubble of expansion becomes its own universe, with its own laws, its own constants, its own possibilities. Some might never form stars, some might collapse in an instant, and some might give rise to light, to chemistry, to life, to thought. In this view, our observable cosmos is only one wave in a vast sea of creation. Infinity may not describe size, but diversity, an endless field of realities, each with its own version of time and space. We cannot yet test this idea. The other universes, if they exist, are forever beyond reach, beyond observation. And yet, the mathematics of inflation, the patterns of quantum fields whisper that it might be true. Perhaps the cosmos is infinite, not because it stretches forever, but because it renews itself endlessly, each universe born from another like ripples on a boundless ocean. And still there is something more intimate in this vastness. For the same equations that describe cosmic expansion also describe the curvature of atoms, the fields that pulse within your own body. The fabric of space-time, runs through you. Every cell, every thought exists in the same continuum that carries galaxies apart. The expansion of the universe happens everywhere, not just between distant stars, but between particles, between moments. When you breathe the air you draw in contains atoms forged in the hearts of stars that exploded before Earth was formed. Their light has cooled their dust, now woven into you. You are, in truth, a small region of the universe learning to know itself. So when we ask if the universe is larger than infinity, we are also asking if consciousness can ever reach its own boundary. Perhaps awareness is a reflection of infinity, endless, centerless, forever exploring itself. If you could float outside time and look back, you would see that everything, every galaxy, every star, every Voyager, and every thought is part of a single structure. Not separate, not scattered, but connected by the same invisible geometry. The filaments of galaxies resemble neurons. The cosmic web resembles the living mind. Patterns repeat from the smallest particle to the grandest cluster. The infinite reflects itself at every scale. In this way, the universe is not something we look at, but something we look through. Every act of seeing is a continuation of its unfolding. Every question we ask adds another thread to the tapestry of understanding. Infinity is not something distant. It is here in the act of asking. There is a quiet comfort in this realization. The universe may be unbounded, but it is not indifferent. Its laws are gentle, consistent, patient. Stars form, live, and die. Galaxies drift and merge. Atoms find each other and become life. From simplicity arises complexity, from chaos harmony. Infinity is not chaos. It is order too vast to see all at once. So when you gaze into the night sky, know that the darkness between stars is not empty space, but the unseen continuation of everything. There is no end to it. No outer edge, no final wall. Just motion, just light, just time quietly unfolding. And perhaps that is enough. Perhaps to live within infinity is not to understand it, but to rest inside it, to accept that there will always be more, that every boundary is temporary, that every answer is another beginning. The Voyagers continue outward. Hubble and Webb continue inward deeper into light. And we here on our turning world float in the middle of all directions, a midpoint between the very small and the very vast. Every heartbeat, every breath is part of that same expansion. You are in your own quiet way, infinite too. Infinity breathes quietly. It expands endlessly, yet calmly, like a tide that never retreats. Galaxies drift apart, stars age and fade, light stretches thin with distance. In this immeasurable calm, there is rhythm, a vast, patient order. And yet even in that balance, there are whispers of something strange, something vast enough to move clusters of galaxies, something invisible, something that lies beyond even the universe we can see. Astronomers call it the dark flow, a name born not of mystery alone, but of observation, a quiet anomaly found in the oldest light. The story begins with the cosmic microwave background, the faint, ancient glow left behind from the Big Bang. It fills all of space, a low uniform murmur of radiation only a few degrees above absolute zero. It is the afterlight of creation itself, the first visible trace of time. To the human eye, it would be invisible. But to the instruments aboard NASA's WMAP, and later the Planck satellite, it appears as a delicate tapestry, a map of tiny variations, small differences in temperature and density, ripples frozen from when the universe was only 380,000 years old. These ripples tell the story of everything. From them, we learn how matter first gathered, how galaxies would later form, how expansion began and still continues. But among those patterns, scientists noticed something unusual, a faint but coherent motion, as though whole clusters of galaxies were drifting in one particular direction toward the constellations of Centaurus and Hydra. A slow, steady motion at hundreds, perhaps 1,000 kilometers per second. Too fast, too organized, too mysterious to fit within the usual flow of cosmic expansion. They called this phenomenon the dark flow. To understand why this is so strange, we must return to what expansion means. The universe expands everywhere equally, so that on large scales no direction is special. Every galaxy recedes from every other, not because of motion through space, but because space itself stretches between them. This expansion is random isotropic, balanced like dots painted on a balloon as it inflates. But if a large region of the universe appears to move in a single direction, relative to the cosmic background, that implies something beyond balance. It suggests a pull, a gentle tug from beyond the observable horizon from a place we cannot see. Something large enough, massive enough to influence even entire clusters of galaxies. Astronomers first detected this drift by studying the kinetic Sunyaev-Zeldovich effect, a subtle distortion of the cosmic background light as it passes through the hot gas of galaxy clusters. When that gas moves, it slightly shifts the frequency of the radiation, a faint fingerprint of velocity. By measuring hundreds of clusters, scientists found that many shared a common motion, as if all were part of a grand invisible current. It was a bold claim. For if true, it meant that the universe we can see was not the whole of what exists. Something beyond the edge, beyond the 93 billion light-year bubble of our visibility, was exerting a gravitational influence strong enough to pull entire superclusters in one direction. Imagine rivers of galaxies flowing not through space but through space-time itself, not random, not chaotic, drifting in a single collective tide. What could cause such a flow? The possibilities are as vast as they are profound. Some suggest that the dark flow could be the lingering echo of conditions before the Big Bang, a remnant from a time before our observable universe began to inflate. If inflation was not perfectly uniform, then some regions might have carried extra mass or energy, creating a gravitational imbalance still felt today. Others imagine something even grander, that the universe we see is not alone, that beyond the limits of our light lies another universe, or many, each with its own laws, its own gravity, its own origin. If two universes once brushed or overlapped in the early moments of existence, the immense structure of one could tug upon the other, a shadowy handshake across the void. Perhaps the dark flow is that touch, that echo, a faint reminder of something older and larger than our cosmos itself. And yet, not all agree. The Planck satellite, with instruments more sensitive than WMAPs, found little evidence of the same motion. Its maps of the cosmic background show a universe remarkably uniform, its small fluctuations random, its symmetry largely intact. Some scientists argue that the dark flow is only a statistical illusion, a pattern conjured by the human tendency to find order in noise. Perhaps the cluster's motion is just coincidence, a natural variation among random velocities. The universe, they say, needs no hidden giant to explain its drift. But even in doubt, the question remains alive. Because the data are not definitive, and the cosmos is too large for easy certainty. Even now, new telescopes re-examine the clusters, comparing their directions, their distances, their relationship to the underlying cosmic web. The dark flow is not confirmed, but neither is it disproven. It exists for now as possibility, a whisper at the edge of understanding. If you imagine it, if you let the idea breathe, the image is astonishing. Whole galaxies, billions of them drawn together in a slow, silent drift, sailing toward a destination we will never see. A motion older than stars, younger than forever. It is a reminder that even the universe, vast as it is, may be part of something larger, still a tide within a greater ocean. It gives scale a new meaning. We speak of the observable universe as though it were complete, but that word observable is a boundary of our own making. It defines not what exists, but what we can know. Beyond it, light has not yet had time to reach us. But distance does not mean absence. What lies beyond still exerts its presence, still shapes the motion of what we see. Even here in the quiet center of our knowing, we are being pulled by things unseen. There is a quiet poetry to that idea. That we tiny beings on a pale blue world are part of a motion that began before time. That our galaxy, our cluster, our entire observable sky moves like a leaf, carried by a current whose source lies beyond our horizon. We cannot see it. We can only infer it from patterns in ancient light, from the way the universe seems to lean. And isn't that true of much of life? We are moved by things we cannot see, by gravity, by memory, by love, by curiosity. Invisible forces shaping visible motion. The cosmos, it seems, is the same. What lies beyond light still draws us onward. If the dark flow is real, then it may hint at structures larger than any we've imagined. Our universe is already organized into vast hierarchies. Stars form galaxies, galaxies gather into clusters, clusters into superclusters, superclusters into filaments, woven through immense cosmic voids. These filaments span hundreds of millions of light years, creating a web-like structure, the architecture of everything we can see. But if something beyond even that web exists, some colossal mass or field exerting influence, it would belong to a scale beyond comprehension. Perhaps a great attractor. Beyond all attractors, a gravitational basin shaping the flow of existence itself. In our local universe, astronomers already know of such influences. Our Milky Way, for instance, along with thousands of other galaxies, drifts toward a region called the Shapley supercluster, a dense congregation of galaxies whose gravity tugs upon us from 650 million light-years away. Before that discovery, we thought we were moving toward another mass, the Great Attractor near Centaurus, a gravitational basin hidden behind the dust of our own galaxy. These flows are local, measurable part of the cosmic web we inhabit. But the dark flow, if it exists, extends beyond even these, beyond all visible structure, beyond time's oldest light. Imagine standing outside on a still night looking upward. The stars appear motionless, but they are not. Each one moves not only around the center of the galaxy, but with the galaxy itself, which moves with its cluster, which moves with the local supercluster, which moves with the cosmic web, which may itself be drifting slowly toward an unseen destination. Every layer of motion carries within it another. And yet, from where you stand, the night feels calm. Stillness, after all, is often motion too vast to notice. Perhaps the dark flow is simply that the stillness of something moving everywhere at once. The quiet evidence that the cosmos in its endless serenity is never entirely at rest. There is comfort in knowing that the unknown remains, that even after Webb's deep fields, after Hubble's long stares, after the Voyager's long drift into night, there are still mysteries untouched. The universe keeps its secrets not out of cruelty, but out of abundance. There is always more to reveal, more to ask, more to feel. The dark flow may be real or not. It may be a clue to something beyond the observable or merely the echo of randomness mistaken for pattern. But in either case, it reminds us that science and wonder are not opposites. They are the same motion, one seeking to understand, the other to feel. And so even if no definitive proof comes, the idea itself holds value. It stretches our imagination beyond what we can measure, inviting us to remember that the universe, for all our instruments and equations, remains a mystery larger than the human mind. And that is good. A cosmos without mystery would be smaller, flatter, less alive. But ours continues drifting, expanding, singing through time. Perhaps someday, far in the future, when telescopes orbit stars and distant galaxies, new observers will look outward as we do now. They will map their own horizons, measure their own background light, and find their own mysteries at the edge. Perhaps they too will wonder whether something lies beyond their reach, whether motion itself whispers of another realm. And maybe they will give it another name, not dark flow, but something softer, the lure, the drift, the call. The dark flow is not just a hypothesis. It is a metaphor for curiosity itself, the human tendency to move toward what cannot be seen, to follow the pull of questions into the unseen dark. We are, in a sense, part of that same motion. We are drawn forward by mystery carried by invisible forces toward understanding. As the universe expands, as galaxies drift apart, as time stretches thinner, that motion never stops. It is not merely physical. It is existential. The same drive that sent the Voyagers outward, that raised Hubble into orbit, that built Webb's golden eyes, is the same current that drives galaxies through space. The universe expands, and so does wonder. And as you lie here beneath the quiet sky, you are part of that same expansion. The atoms within you stretch infinitesimally with the universe's breath. You move not through the cosmos, but with it in harmony and flow. Perhaps that is the truest form of the dark flow. Not a motion of galaxies, but a motion of thought, the endless reaching beyond our own horizon, the eternal curiosity that binds us to the stars. And somewhere beyond the observable, beyond what even imagination can grasp, something vast and unseen continues to move. Slowly, silently, patient as time. You may rest now in that knowing that, even as you sleep, the universe continues its gentle drift, flowing outward into forever. You have traveled far tonight, through light that began before memory, through the orbits of frozen worlds, through the soft breath of infinity. The stars have turned above you, and now the night grows still again. The universe continues quiet, constant, without hurry. Galaxies drift as dust upon a river of time, and between them the silence hums, ancient, gentle, endless. Somewhere far away, Voyager still drifts through darkness, its signal faint but steady, its golden record turning slowly like a heartbeat. Hubble watches from its bright orbit, and Webb, with its golden eyes, listens for the light of beginnings. All of them moving, all of them waiting, each carrying a small piece of our wonder. And you too are part of that motion. The same atoms that blaze in stars breathe quietly in your chest. The same rhythm that turns the galaxies moves through your pulse, through the soft weight of your breath. There is no need to reach farther tonight. The universe is already here in the stillness of this moment, in the space between heartbeats, in the dark that is never truly empty. Let the vastness fade to quiet. Let thought drift like starlight dissolving into morning. Everything moves, everything rests, everything continues. You are safe within that endlessness. You can let go. The stars will keep their vigil. The galaxies will turn without you needing to follow. The universe expands in silence. You may rest within it now. Sleep well, and let the night carry you home calmly, endlessly, into the gentle dark.